Now simplifying this equation, we will get the path difference twice mu t cos r plus theta is equal to twice n plus or minus 1 lambda by 2. So this is the path difference condition for brightness. This is equation number 3. Similarly, we can write the condition for darkness. Second, condition for darkness. We know that path difference must be equal to odd multiple, that is 2n plus or minus 1 of half the wavelength, lambda by 2. So comparing this path difference with the condition we have got here, we can write twice mu t cos r plus theta plus or minus lambda by 2 is equal to twice n plus or minus 1 lambda by 2, or simply twice mu t cos r plus theta is equal to n lambda. So this is the condition for darkness for thin wedge-shaped film. This equation number 4. Similarly, we can write the conditions for transmitted system also, provided that we have to neglect the term plus or minus lambda by 2. Important point, that is fringe width or band width. It is also indicated by a letter beta. Now in thin wedge-shaped film, we can see the pattern, interference pattern of alternate bright and dark fringes like this. Bright, dark, and like this. Now, what is fringe width? The distance between two consecutive bright or dark fringes is called as the band width or fringe width. For example, the distance between these two bright from this to this is called as the fringe width, beta, or the distance between the two consecutive dark fringes is called as the fringe width. Now that is what we have to find out. Now consider this figure. In this figure you will see that this is a wedge-shaped film, OA and OB. These are the two surfaces. Now when light falls here normally on this, you will see that nth dark fringe at this particular point, that is Pn, Qn. So you can see the nth dark fringe here like this, then bright, and again next dark fringe you will see that is n plus 1th dark fringe. Let's say you are observing here at this point Pn plus 1, Qn plus 1. Now we have the condition here for thin wedge-shaped film, the path difference condition for darkness, that is twice mu t cos r plus theta is equal to n lambda. So this is the condition for darkness. This is equation number 1. Now if we consider the normal incidence for normal incidence, angle R is equal to 0, and this equation can be simplified as twice mu t cos theta is equal to n lambda. This is equation number 2. From the figure we can write here, from the triangle OPN QN, OPN QN, we can write here tan theta is equal to Pn Qn divided by OPN is equal to T. Pn Qn is the thickness of the film, and OPN is nothing but the distance of the fringe from the origin, that is xn. In other words, we can write this term, that is thickness T is equal to xn into tan theta. This is equation number 3. Now putting this equation number 3, put equation number 3 in equation number 2. So we will get twice mu, instead of T we'll write here xn tan theta into cos theta is equal to n lambda. Or so this is equation number Similarly, for the next dark fringe, we can write twice for next dark fringe. We can write twice mu xn plus 1 into tan theta is equal to into cos theta is equal to n plus 1 lambda. This is equation number 5. Now subtracting equation number 5, equation number 4 from 5. So we will get twice mu, the common term as it is, that is tan theta into cos theta into xn plus 1 minus xn is equal to lambda only. Now simplifying this, twice mu t, sorry, no t here. So instead of this tan theta, we can write here sin theta upon cos theta into cos theta. Now this xn plus 1 minus xn is nothing but the difference between the two consecutive dark fringes, that is the fringe width beta, is equal to lambda. Therefore I can write here simplified value, that is beta is equal to lambda divided by cos theta will get cancelled here, remaining terms twice mu, this is sin theta. So this is the expression for fringe width, that is beta. This is equation number 6. If the angle theta of the wedge is very small, that is if theta tends to 0, very small, we can write sin theta tends to theta, and therefore the expression for fringe width can be written as beta is equal to wavelength upon twice mu theta. Again, if the film is of air, that is for air film, refractive index mu is equal to 1, and therefore fringe width beta can be written as beta is equal to lambda upon twice theta, where theta is in radians. So in this way we can find out the fringe width beta, equation number 7.